the first day of term 4, and we always start our notes by giving them a title. So this is Algebra 2, and we are beginning Unit 1. Okay. I always like to number the days, so we go by day numbers in here. This is day 1, first day of class. So I'm gonna write day 1 notes. I like to write the date on there as well. It is March 24th, which is wild. I feel like it was just January. It's crazy how fast time is flying. Okay. So Monday, March 24th. All right. So we are going to talk about quite a few things in this class. And the first thing that we're supposed to talk about is something called a quadratic equation. Now, this is what that looks like. We are not going to start there. We're going to go a little step before that, and we're going to build up to that. Just because I feel like that's a little heavy to start on day 1. So, here's what we will be starting on. We are going to talk about some of the basic algebraic operations that we will be using in this class. And the first one that we need to talk about should be very familiar if you have just taken Algebra 1. If not, I'm going to familiarize you with it here now. We are going to talk about like terms. Like terms. Does anybody know what a like term is? Yes. It's going to be numbers that are attached to the same variable. What's a variable?
It's letter.
A letter. Yes, it's a letter. That letter is standing in place of a number that we do not know. So let's write a little definition out to the side. The definition part is optional. If hearing it verbally is enough for you, that's great. I like to just write it out. Like terms are terms or numbers with the same variable and exponent. And I will show you examples so that this makes sense. So, for example, if I have 3 different terms, I have a term 3x, and I have the term 5x, and then I have minus 2x. There are 3 terms here, 3x, 5x, and negative 2x, or minus 2x. Are these like terms?
No.
They are like terms, yes, because they all have the same letter attached to the number. It's an x on every single one of them. Now, there is no exponent, so they have the same exponent, none. It's the same. Whenever we have like terms, this means that we can add and subtract them together like normal numbers. It means I have 3 x's, 5 x's, and then I'm taking away 2 x's. How could I solve this problem here? What would I do?
Combine all the numbers.
We're just combining all the numbers. We can kind of just ignore the x's. and go left to right. What's 3 plus 5? 8 minus 2?
6.
6. So our answer here is 6x, because now there is an x attached. So this is an example of a problem where we can combine like terms because the letter is the same. We can add the numbers and subtract the numbers. Okay. What if I gave you, though, something like this? 4x squared plus 6x minus 2x squared plus 3x. Okay. Now we have something a little bit different. How many terms do I have here? How many altogether? There's 2 types, yes. 4. There are 4 terms. 1, 2, 3, 4. 4 different terms. Do each of these terms have the same variable?
Yeah.
Yes, they all have an x. Does that mean that they are all like terms?
No.
No. Why?
Because some have exponents.
Because there is also exponents, okay? A quick reminder of what an exponent is. It is that little number that is sitting above something. It could be above a number or it could be above a variable like it is here. So we have 4x squared. X squared, that squared is the exponent. We cannot combine terms that don't have the same exponent. So even though these both have x, because only one of them has that squared exponent, I can't put these together. So these first 2 terms are not like terms. I can combine the ones that do have the same though, right? So with all of these 4 terms here, let's start with our first term, 4x squared. Okay, I am going to look at the part that tells me how I can match this to other terms. I see that I have x squared here. Are any other of my terms containing x squared? Yes, I have a negative 2x squared. Okay, so since these both have x squared, are they like terms?
Yes.
They are. Great. Let's look at the next variable. I have 6x. There's no squared or anything, so I know that I'm looking to see if I have other terms with just an x. Do I?
Yes.
I do. 3x at the end. So I'm using different colors to show the difference here. But since we have 2 different sets of terms, we're kind of doing 2 problems here. I cannot combine these all together, but we can separate the parts that are the same and solve it that way. So let's start from left to right. I have my 4x squared, and we said that there's a like term here, the minus 2x squared. What I'm going to do is I'm going to sort of rearrange this problem. I'm going to take my 4x squared minus 2x squared, and I'm going to solve that down here at the bottom. I'll rewrite it. 4x squared minus 2x squared. What would that give me? 2x squared. 4 minus 2 is 2. We're just looking at the number in the front. The x squared is like a symbol. We're really not touching it. It's just telling us that we can put those together. So 4 minus 2 is 2x squared. Okay, I'm going to cross these off because I used them and I'm done with them. What should I do next? Yes, now let's look at our 6x and our 3x. 6x plus 3x. And what is 6x plus 3x? 9x. Good. So now I have my two different terms. I've combined everything that I can combine. What would my final answer be?
2x squared plus 9x.
Yes, yes. So to write this as our final simplified answer, we would write 2x squared plus 9x. And that is our answer. Because we don't know what x is, this is as far as we can go. Getting our brains working again. Is this all coming back to us a little bit? Hopefully, hopefully. Okay. Any questions about the first two problems we've done together so far? Or is everybody getting it? We got it? That's good. That's good. Okay. I don't think we need to do another example like that. Let's look at something else. Okay. So this is our review of like terms. Two terms are like terms and can be combined if they have the same variable and exponent. Okay, both have to be the same. That is important. So next, we're going to do a quick little review of a very fun property. This is called distribution. Distribution. Does anybody know what distribution is? Kind of a loaded question I'm asking you.
Distribute any number outside of parentheses.
Yes, yes, yes. So distribution is something that we see when a problem is written in a certain way where there are parentheses. For example, if I have 5 parentheses, x plus 3. If I wanted to solve this or simplify it, we would use distribution. Now that I have an example here, a less loaded question would be, how do I solve this? How do I use distribution to solve this?
5 times x and 5 times x.
Yes. So with distribution, all that's happening is it is repeated multiplication in a way. I'm going to take 5 times whatever is inside the parentheses. So 5 times x, which is what? 5x. And I'm going to bring down my plus sign. 5 times 3 is 15. And that's your answer. Not too bad. Distribution is just multiplication. It's multiplying. So multiplying each term in parentheses. Okay, now let me give you a tricky distribution problem. How about this is where everybody starts having a panic attack when I start giving you negative numbers. So how about negative 3 times 2x plus 4? What happens when I multiply a negative number times a positive number? You get a negative answer. Yes. Quick review on multiplication rules for positives and negatives. And also, quick side note: each of you in those long, colorful bins on the tables should have a pad of sticky notes. Sometimes I use sticky notes to write little side notes to you guys that I don't want to put on my paper. If you ever want to also include the side notes in your notebook, feel free to use the sticky notes. If there are no sticky notes at your table, let me know. I have lots of extras, and I'm happy to share. So, quick side note. And I use lots of colors in here. Colors I find helpful. But you know, each person has a preference. Don't feel like you have to do everything the way I do it. But we're going to talk about how we get different types of answers in multiplication and division. So, for example, if I have a positive number times or divided by, both are the same, and I do it times another positive number, will my answer be positive or negative?
Positive.
Positive. Two positives will always give you a positive answer. There's no way that I can come up with a negative answer if I'm only dealing with positive numbers. And again, if I'm ever writing too small or you're having a hard time seeing, let me know. I really don't want anybody to be struggling. No big deal. I'm happy to adjust as needed. Now, what if I have a negative number times a negative number? What kind of answer would I get?
Positive.
Ah, a positive. What? That makes no sense, right? How do I do positive and positive make positive, but negative and negative also make positive? How does that work? Does anybody know how to explain that?
Honestly, I just looked at it as there's two lines, one rotates to make a plus sign.
Yes.
While
Yes.
the two positives, those directly align, which makes it to where they remain positive.
Yes. So we like to think of the two negative signs as sort of canceling each other out and becoming positive. You could also think of it the way that Ella was sort of explaining it, where another side note, this one you really don't need to write. I'm just using it to explain something. If I had, for example, -3 times -10, something you can think about doing is taking the negative signs over to your answer. It's like, okay, well, I'm going to bring this negative over here, and I'm going to bring this negative over here. And since there's two of them, you can make a plus sign with them. So, and 3 times 10 is 30. So your answer would be positive 30. The other thing is that negative means opposite. So if I start with a negative and I multiply by a negative, the opposite of a negative is a positive. So we're switching signs. My favorite way also to remember this is if you multiply numbers that have the same sign, meaning they're both positive or they're both negative, you will always get a positive answer. Two positives make a positive. Two negatives make a positive. Signs are the same, we get a positive answer. The only way that we get a negative answer is when the signs are different. For example, if I have a negative number times a positive number, or a positive number times a negative number. And, I tell you guys you don't need to memorize anything in here. However, this is one where memorizing is very helpful because it will save you so much time in the long run. However, if you ever do forget, you can always double check on your calculator. I am a big believer in calculators. I think that they are available to use in the real world, so why not in math class, okay? I'm not going to make you guys memorize something that you will never use again in real life. However, this might be used in real life. If you're like doing money things and adding up balances and charges and stuff, it'd be useful. So anyway, now back to this problem. I have -3 times 2x. That's a positive 2x. What's going to be the sign of my answer here?
-6.
Yes, it'll be negative because I have a negative and a positive. Negative, positive, negative answer. So our answer for the first term here, -3 times 2 is -6. And there's an x. -6x. Great. Now, what do I do next?
-3
Mm-hmm.
times 4.
Good. -3 times 4. What's that going to give us?
-12.
-12. So we write -12 since it is -12. And that is our answer. Okay. So we've done one with a positive, we've done one with a negative. Does anybody feel confused about either of these problems we just completed? Everybody's got that? Good, good. That is wonderful. Okay, so there's our quick little review of distribution and of course the negative and positive multiplication rules. You will see this at some point. So, does anybody still need this or can I move to the next page? I'm going to go ahead and move this. Something I like to do with each page is I like to number my pages. You don't have to do this. I'm not checking your notes. I just do it because I lose things and this helps me stay a little more organized. So it's page 1. And I'm going to title my next page Still Algebra 2. This is page 2 today. Day 1 notes. Continue. The next thing we're going to talk about is exponents and what we do when we multiply them and divide them. Now, especially my Algebra 1 people from last term, we just did a whole bunch of this, so we're picking up right where we left off. Let's write a little title here. Exponent multiplication. And underneath this title, I'm going to write a little formula. That may make a bit more sense as we move forward. It might make sense as soon as you see it. Times, and this little dot symbol is often used as a multiplication symbol, especially as we move into higher level algebra, because I hate that we teach multiplication as an x. It is so confusing when we bring x as a variable in. So whenever I write multiplication, I will try to make a point to either use this dot or to use parentheses. That way we don't mix up, is this an x or is it a multiply sign? Okay, so assume that if you see an x, it's a variable, not a multiplication symbol. And of course, if you're not sure, you can always ask me. So x to the a power times x to the b power equals x to the a plus b. So let's give an example. For example, x to the fourth power times x to the third power. This is another way to write multiplication, doing it with parentheses around one of the terms or both equals. Okay. So by looking at the formula above, that whenever x to the a is multiplied by x to the b, we get x to the whatever a plus b is. Can any of you take this and sort of translate it in your mind into how we would solve this problem I just gave you? Yes.
Just add the exponents together.
Yes. Yes, that's all we do. That's all we do. So in this scenario, my A is 4, my B is 3. So A plus B would be 4 plus 3. So I'm really going to do x to the, I'm just adding the exponents. 4 plus 3, which is what? 7. So our answer is x to the 7th power. That would be our answer. We just add. Now I'm going to show you why that works. And this will be, again, a side note. So optional. If you see this and you're like, yep, that's good for me, great. If you're somebody that likes more of a visual explanation, this is for you. So whenever we have an exponent, for example, x to the 4th power, what does this really mean?
4 x's.
It's 4 x's. It means I'm taking x times x times x times x 4 times. So we could write this as x times x times x times x. This is the same as that. X to the 4th is the same as x times x times x times x. We can also think of x to the 3rd power as x times x times x. So if I am doing x to the 4th times x to the 3rd, I'm going to show you how we can replace that with all of these x's written out, and it will make it very clear how x to the 7th power is our answer rather than x to the 12th power, for example. That's a mistake a lot of us would make, is x to the 12th. It's actually the 7th, and I'll show you why. If I take x, 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 there's my x to the 4th, times x to the 3rd. How many x's do I have now? 7. This number tells me how many times will I multiply my base, which in this case, my base is x, okay? So I'm taking x times itself 7 times total. See that? So that's really what's happening. If you ever forget that you should add, sometimes a better way to do it is to write it out in more of an expanded form and see how many x's do I have in a line now. You know, sometimes that helps a little. So x to the 7. That's our answer. How about x times x? What is x times x?
X squared.
X squared. Yes. When you don't see a number for an exponent, you can assume that exponent is actually 1 because I have x 1 time here. So x to the 1st power times x to the 1st power is just like x to the 1 plus 1 because there is an invisible 1 here. So we end up with x to the 2nd power, or x squared. We could also say, well, x times x, there's two x's there, and I'm multiplying x by itself twice, so my exponent is 2. And that's how we get to that answer. Okay, great. What if I were to throw in a coefficient? I'll tell you what that word means if you're not sure. Let's do 3x times x to the 5th power. Lots of words. If you are unsure what a coefficient is, this is a coefficient. The 3, for example, in this problem, a coefficient is just a number that comes before a variable. Now, at any point, whenever I'm teaching you or speaking to you as a class or one-on-one, if I say a fancy math word like coefficient and you don't know what it means, I don't want you to get lost or get behind because you're trying to figure out one word. Please feel free to stop me and ask me. I never mind clarifying. The last thing I want is for any of you to leave this room confused. So I will never be upset if you stop me and say, I don't know what that means. Can you explain it? Okay. Just want to preface with that. Okay. Does anybody know how we could solve this one? We're distributing. We really are distributing. I'm taking 3x times x to the 5th power. We're multiplying. So, what am I going to do?
3 times 1 is 3. Then you just have to add 1 of that.
Yes.
Make 3 to the
Yes.
6th power.
Yes. So, what Ella just said is we are going to multiply our 3 times whatever the number is in front of x here, which when there is no number, it's an imaginary 1. Okay, I have 1 x to the 5th power. So 3 times 1 is 3. And now we're looking at our exponents. We've multiplied our coefficients, so we go to exponents next. I have x and x to the 5th power. When there is no number, what number do we assume?
1.
1. Okay, and Ella, I know you got me the right answer. I have x to the 1st power, x to the 5th power. When I multiply those, we get x to the 6th power. 1 plus 5 is 6. And that would be our answer. Any questions about that? Okay. Okay. Now, this is all meant to be a review. So, something I do want to share with you guys, just for full transparency, when I was in high school, I myself had a class that I remember I walked into, sat through the first class, and realized I was completely lost the whole time, didn't understand any of it. I went up to my teacher and was like, I don't think I should be in here. Okay. I do want to mention that if while we are going through today's topics, this is all review from Algebra 1. If any of you are totally lost at the end of today, come and talk to me and we'll talk about where you should be. I'm not saying that I'm looking out and anybody looks totally lost. I do just want to mention it so that nobody gets stuck too far into a class that they don't feel they're ready for. So just mentioning that really quickly. But there are a few examples of our exponent multiplication. Basically, you just add those numbers, that gives you your answer. Let's do one last thing, and then I'm going to let you guys get out a little early today. We're going to finish our review up here. So the last thing I want to talk to you about is exponent division. We just did multiplication. Now we're going to do division. And this will be the last note we take today. I'm going to write another formula. This time I'm writing x to the a power divided by x to the b power equals x to the a minus b. It's just the opposite. So just like multiplication, when we are multiplying exponents, we just add them. When we are dividing exponents, we are subtracting numbers. Now we're doing the opposite. So to give you an example of that, let's say I have 5 we're going to do 25x to the third power divided by 5x. Okay. So now I've given you a problem that has two terms. And in each of these here, we have a coefficient and an exponent and a variable. Oh my goodness, a lot going on here. What should I do first? Yes, I heard a bunch of people say it. You all are correct. We're going to do 25 divided by 5 first. Let's mess with our coefficients first, always. So what is 25 divided by 5? 5. I'm just going to write that. We are first doing 25. Again, this part is optional. I'm just writing it to have something to look back at. So I did 25 divided by 5, which is 5. So 5 is the first part of my answer. So I'm done with my coefficients. What do I do next? Say it again.
3 minus 1.
3 minus 1. Because next I have x3 and then x with no number. But we assume that that invisible number is 1. So 3 minus 1, since we're dividing, which is
2.
2. So right here, I will write the 3 minus 1 equals 2. And that would be our answer, 5x to the second power, or 5x squared. So we just do one thing at a time, we divide. The only part that I think gets really tricky is remembering to switch from actual division to subtraction whenever you go to the exponents. We will get so much practice with this, it will become second nature at some point. However, you know, this is a little review. I'm just kind of giving it to you quickly today. But before I do one more, do we have any questions about how I got to this answer here? We all get it? Okay, cool. Let's do one more. How about 48x to the 10th power? And I'm going to write the problem differently this time. I'm going to write it as a fraction over 6x to the 6. So, anytime you see numbers written as a fraction or terms written as a fraction, it's just a division problem, okay? All this is division. 48x to the 10th power divided by 6x to the 6th power. So, what should I do first?
Coefficient.
Coefficients first. 48 divided by 6. What is 48 divided by 6? 8. So, we're going to write 8 as our first number. 48 divided by 6. And what do I do next? 10 minus 6, which is 4. So what's the next part of my answer? X to the 4th power. Good. And we got that by doing x to the 10 by x 6. So we already did 10 minus 6 is 4. And that would be our answer. Okay, that is gonna be it for our little review today. Hopefully this got our math brains kind of functioning again. We will go further with this tomorrow and get into some more actual Algebra 2 topics. If anybody has concerns about anything, feel free to talk to me at any time. I'm always happy to help. If you have children in childcare, do not forget to get them at lunchtime before 11:55. But you guys are free to go. Please do not forget to turn in your classroom agreement signature page by Friday. That is all.